Okay, I hope you figured this out. The absolute difference is $10,000. The question was how much less is my car compared to my neighbor's car? The reference number now is here, my neighbor's car value, which is 50,000. And 10,000 divided by 50,000 turns out to be 0.20, and that is 20%. Okay, so it would be correct. Now, listen again, very carefully. It is correct to say that part A, my neighbor's car is 25% more than my car. It's also correct to say that my car is 20% less than his car. Notice the difference in percentages? Yeah, that's really confusing, isn't it? That's I hate to say this, but that's mathematics, okay? And that's because you have now the relative difference, $10,000 relative to what, based on not my car, but his car and his car value. So 10,000 happens to be 20% of his car value, which is 50,000. Okay. So as difficult it is, and I'll show you even something more complicated here in just a minute. It is true. Let me just say this again. That my car, sorry, my neighbor's car is 25% more than my car. At the same time, my car is 20% less than his car. Okay. All right. I'm talking about the value or the price of the car. All right, so part D. Now, there is a slight difference when you talk about of and more than or less than. Okay, so let's imagine product A. That's $40. Okay, so the product A has the ticket price value of $40, and you have a product B which costs $120. Maybe what do you think of this? Maybe like A is a cheap piece of clothes, or let's say A is I don't know, a pair of shoes, real cheap pair of shoes. B is a pretty decent pair of shoes that costs $120. All right, now what's the difference? Duh, you say it's $80. Yes, $80 is called the difference. Okay, and this is the absolute difference, right? Yes, clearly A costs more, $80 more than B. B costs $80. I'm sorry, A costs $80 less than B, and B costs $80 more than A. No problem here. Okay, but if you're trying to say B costs what percent more than A? More than A. Okay, when you're talking about more than, the difference is 80, right? So the difference is 80, and you want to say B costs how much more than A? So what you'll have to do is, 80, which is a difference, divided by 40, which is 2. Now, 2 is a decimal number, 2.00, and that's 200%. So the answer to this question is B costs $200, 200% more than A. Does that make sense? See, B actually costs $80 more than A, right? But $80 happens to be exactly twice as much as the price of A. So that is $200 of the cost of A. And so therefore you can say B costs 200% more than A. Right? That is the correct statement. Now the cost of B, now what's for this? I said more than first. This time it's of, and that's why this section is called of versus more than. It makes a big difference between the word of and the term more than. If you say the cost of B is blank percent of the cost of A, now you're talking about not the difference as in more than, but the cost of A and cost of B. The cost of B is 120. Cost of A is 40. Guess what? 120 divided by 40 is 3, or 3.0, which is 300%. So it will be correct to say the cost of B is 300% of the cost of A. Okay, so the cost of B, the price of B is 300% of the price of A, even though B costs 200% more than A. Confusing? Okay, if you're confused by this, you may want to review this, maybe listen to this repeatedly. you may want to try some exercises a few times just to make it clear in your mind. All right. Now, A is the cheaper one. A costs what less than B? What percent less than B? Well, remember when we say less than, we are using that ratio, the difference, 80. But this time, less than B. So B, the price of B is the reference number. Well, that's 120. So you divide 80 by 120, and that turns out to be 0.6666. And that's roughly 60.6%. Or I should say round up to the next whole number, 67%. So it would also be true to say A costs 67% less than B. Is that right? I'm saying in the first statement, B costs 200% more than A, but A only costs 67% less than B. That doesn't seem right, or does it? Well, it is, okay? And that's why percentage is such a, even though that's such a powerful and useful and convenient expression, it could be quite confusing because many times people don't pay attention to what the base number is, what the reference number is. When you say more than or less than, right? The number that comes after the word than, T-H-A-N, okay, clearly is the reference number that goes in the denominator. So when you say A costs blank percent less than B, you have to divide the absolute difference by the price of B. And the answer is 67% less than B. Now the cost of A is what percent of the cost of B? Now we are only comparing the cost or the prices. And so we are not going to use 80, which is the difference. The cost of A is 40. The cost of B is 120. Remember, of, this word of tells you that the cost of B is the reference, the denominator. 40 divided by 120 is 1/3, which is 0.3333, and that is roughly 33%. Now, look, we have just said the same thing 4 times over, okay? And every one of these 4 statements is correct. Remember, A is a $40 pair of shoes, B is a $120 pair of shoes. You can say B costs 200% more than A. That's correct. The cost of B, or the price of B, is 300% of the price of A. That's also correct. You can say A costs roughly 67% less than B. That's also correct. You can also say the cost of A is only 33% of the cost of B. Which one are you going to use? Okay, well, that depends on what you want to emphasize. If you want to emphasize the huge difference between them, you can say 300% because that sounds like a shockingly big number, right? If you want to minimize the difference, maybe you want to use only 67% less. You know, that sounds like a reasonable thing. It sounds less drastic than, 33% relative difference. Okay, I hope you get this. Again, you will have plenty of opportunities to exercise these in your homework. All right, number 2, if an item is 25% off. Now, this is also a very misunderstood concept. In fact, I would say the vast majority of the people who live in America or in any given society will probably not get this and the few problems that would follow, okay? Now, this is very important, and I think it's such an important thing because I don't want you to be fooled by percentages. And this is one of the easiest ways in which people in general make errors about percentages. I'll tell you what I'm talking about. If an item is 25% off, then how much are you paying? If it's, see, the thing is, the whole thing is 100%. And if you're not paying the 25%, guess what? You're paying the rest of that, which is 75%, right? Now, this is very important. I know this sounds simple, but this is the basis of what we're going to be doing in just a second in order to not be fooled by retailers or businesses or anybody else, okay? Now, remember this again. If an item is 25% off, if you're buying something at a 25% discount, then you are paying 75% of the regular price. 75% because 100% minus 25% is 75%. Okay, keep that in mind. Now look, number 3, suppose the pair of nice shoes is on sale. Okay, so imagine you have a very nice pair of shoes. You've always wanted to buy these shoes, and you walk to the store, and then you find out it's 20% off today. Wow, I'm going to buy this. And so you take your shoes to the cash register, and they say the sale price is $100. Okay, all right. So 20% off gave you the sale price of $100. Now, what was the original price? It'll be incredible to see how many people get this wrong answer. Most people, I think, all right, here's what happens. Most people think 20% off, and I get 100%. And so if you add 20% of $100, that's 20%. So the regular price must have been $120, right? 120 would be 20% more than 100. That is absolutely correct. But if you ask me what the original price is, it's definitely not $120. This may actually shock some of you, okay? But look, remember what I said? If it's 20% off, if it's 25% off, you have paid 75% of the regular price. See, the problem is you're using this as a reference number, but it's not. The reference number has to be the original price, because the question you're asking is 20% off of the original price. Let me put it this way. You paid 80% of the original price. 80% of the original price is $100. You see the difference? You are not trying to add 20% to $100. Why not? Because that 20% is not based on $100 sale price. What you're making, the correct statement you're making is that 80% of whatever the original price was, the unknown, is $100. You see that? You're given the part A, you're given the percentage P, and you're looking for B, the original price. So how do you do that? You take the $100 and divide it by 80% written as a decimal number, that's 0.8. And that will give you, by the way, this is again the division, that's going to give you $125. Is that right? Yeah, it is absolutely right. Okay, so, and I don't know how many times I've, taught this. Sometimes students just refuse to believe me. Sometimes they continue to just do the wrong thing. Let me tell you this again, all right? You will probably not, this may sound harsh and mean, but usually I don't give any partial credit or any number of points if you did this common mistake and you say, well, 20% off and you get $100, so the original price must be $120. If it's a 5-point question, you will probably get 0 out of 5 points. Now, why? Because this is such a common mistake. I don't want anybody else, and it's not hard to fix the problem. I don't want any of you to make this mistake as you live for the rest of your life. Okay, so what am I saying here? When I say 20% off, that means you paid 80% of the original price, and 80% of the original price is 100. Then the original price, the reference number, must be obtained by dividing the part, which is $100, by the percentage described as a decimal. So the answer is 100 divided by 0.8, which is 125. The answer is absolutely $125 and not $120. Now, let's go ahead and check this. Let's say, originally it was $125. What's 20% of 125? Well, 10% will be 12.5. So 20% is 20% of 125 is 12.5 plus 12.5. That's 25. So you do get $25 off when you get a 20% discount. And so 125 minus 25 is exactly 100. So this is the right answer. See, the problem is if you take out 20% of 120, that would be a $24 discount. And you would be buying this for $96 and not $100. So, okay, now let's go to E, which is also a misleading kind of thing. Percentages of percentages. Now, what am I talking about? Sometimes because we consider rates to be, or the percentages to be going up and down, like the poverty rate or the unemployment rate or the singles rate or the married rates or divorce rate or whatever. Okay, you have lots of rates that we talk about, and they're all written or described in percentages. So the percentages number changes. All right, so let's say the poverty rate of some city went from 20% to 30%. Not very good news. Okay, but then what do you do with this 20% and 30%? Because these are both percentages. The rate went up by what percent? Well, you could say 30% minus 20% is 10%. Okay, and it does have a meaning because basically it went from 20% to 30%. That is a 10% difference, right? Okay, so it is okay to talk about the 10% change, but the 10% change sounds like it only increased by 10%, but that's not the case. If you went from 20% to, so in other words, what I'm saying is this is the absolute change in percentages. If you're talking about the relative change, then you would have to divide this 10% by the original number, which is 20%, right? And that turns out to be 0.5, that's 50%. So what is, do you see that this is a 50% increase? Because look, if the city has, assuming the city has only 100 people, the poverty population of the number of people in the poverty line, under the poverty line, went from 20 to 30. And that's definitely a 50% increase, because if you started with 20%, 20 people, and if it went to 30 people, the half of these people, the difference is 10, which is half, and that's a 50% increase, right? Anytime a number changes from 20 to 30, that's a 50% increase. So you could say it's a 50% increase, but this is actually the percentage of the percentage. Okay, well, the percentage difference of two percentages. Yeah, it's really confusing, okay? So in order to distinguish these from each other, the first one is often not called 10%, but we will say the difference of the two poverty rates is 10 percentage points, or you could also say 10 points, okay? So I'll just be very careful here, and you say 10 percentage points. And when the media, the news or reports or whatever says percentage points, it clearly indicates, right, that is without any ambiguity, it means the difference in the percentages, the absolute difference or an absolute change in the percentages. So when the number or the rates go from 20% to 30%, you say it's a 10 point difference or 10 percentage points difference. But if you're talking about if you want to talk about the relative change from 20% to 30%, then you can say the relative change is actually 50%. Ooh, that is confusing, isn't it? Okay. But look, don't tell me now. You said, well, you know what? This all the math thing stuff we learn in school, this is irrelevant. We never use this. Listen, you will use this every single day for the rest of your life. Okay. So make sure you know the difference between percentage points and the relative change, which is the percent. This is the percentage of percentages. Okay, warnings about percentages. This is the last thing we want to talk about. And this, to me, this is great, okay? The first thing, I'm going to tell you the two things I'm going to conclude this lesson with. Number one, don't add percentages. Number two, don't average percentages. Okay, so what am I talking about? All right, so look, let's say you get a special item, all right, and you wanted to get something. You are looking for a sale like most people do. And one day you saw your item, your favorite item you wanted to buy half off, okay, 50% off. Great. Oh, but look, you actually are an employee of the store. That's why you've been, looking at this item until you go on sale, that goes on sale. And because you're an employer, you get additional 30% off. So you get a 50% off just because it's 50% off on sale. And additionally, you get 30% off of that discounted rate because you're a store employee. Is that 50 plus 30, 80% off? The answer, absolutely not, okay? And I don't want you to be misled. I mean, after all, if you get half off and another half off, is that 100% off? Is that free? No, of course not. Okay. So how do you calculate this? How would you decide to, how would you solve this problem? Problem solving technique. Remember, maybe you can start with a certain number, like the lady who bought the horse. Start with certain number. Let's say what you wanted to get was $100. Okay. Now you got 50% off. So you knock down $50. Now this is on sale for $50. Okay, that's the sale price. Now you get 30% off of that. Okay, now again, the reason you cannot add 50% and 30% is because these are not based on the same reference number. Okay, so originally the number was 100. So this 50% was based on the reference number of $100. This 30% is based off of or based on the discounted price of $50. All right, what is a 30% of 50? That's 50 times 0.3, and that's $15 off. Okay, so you knock down $15, knock off $15 from 50, you get $35. So what's the answer here? You can buy a $100 item at the price of 35. Okay, so 35. So let's say 100 minus 35 is 65. So the discount, the total discount is what percent? Is 65%. Now you wouldn't get this number easily. I mean, because 50% and 30% do not add up to 65%, right? How do we get the 65% discount rate, which is the correct rate when you combine these? You actually have to do this kind of a calculation, right? You don't have to start with $100. You can start with 1,000 if you want, or you can start with X dollars. And then after the discount, it'll be 0.5X. And 30% off means you paid 70%, all right? So it'll be 0.5 times 0.7, and that's 0.35X. The difference between X and 0.35X is 0.65X, and that will give you the 65% discount. You don't, but you don't have to use algebra. Start with a fixed number, like 100, a nice number, and then you find out you can buy this for $35. That means you don't have to pay the extra $65, and that is a 65% discount. Okay, that's about the only way you can find the correct answer. 65% given 50% off and 30% off. In other words, do not add the percentages. Get that? Okay, 2 more questions. You got a pay cut. Not good news. You got pay cut by 40%. So one day you go to your job and your boss says, sorry, but the business is really slow. I have to either let you go or I give you a 40% off a pay cut. And of course, you don't want to be laid off. So he said, okay, and this is going to be temporary, right? Yeah, it's temporary. You get 40% pay cut one day. And then the next day, something happened and your boss says, look, I have great news. I'll give you 50% raise. So are you going to be happy? You're going to be better off than 2 days ago? Well, what? You can't just do minus 40 plus 50, and that's positive 10. Remember what I said? Don't add percentages. Okay, so you can't do it that way. So what's the right way to think about this? Again, let's start with 100. Okay, now you don't have to start with 100, but just, start with a fixed, nice number. After a 40% cut, what is 40% of 100? That's $60, right? Sorry, $40 off. So your new, maybe this is a daily pay. You used to make $100 a day. Now you make $60 a day after the 40% pay cut. All right, it's followed by a 50% raise. What is 50% of not 100, but 60? 50% of $60. Remember, because the reference number has changed, not 100 now, it's 60. 50% of 60, half of 60 is $30. So you will be given $30 extra on top of $60, and your new daily pay would be $90. This doesn't make sense, or does it? It does, or it should, even though it doesn't seem right. So when you get a pay cut by $40, 40%, followed by a 50% raise, you are not better off than before. In fact, you are worse off than before because you used to get $100. Now, after these two changes, you only get $90. So the overall result is it's a 10% cut because you started with 100 and that's 90. And by the way, this 10% is not because 40% and 50% are different by 10%. That's not how it can happen. You have to actually do a calculation like this in order to find out your end result. Okay, finally, do not average percentages. Let's say a basketball player made 1 out of 2 free throws. Do you remember Shaquille O'Neal? Never mind. Okay, this person made only 1 out of 2 free throws in the first half. Okay, that's 50%. But then this player made 7 out of 10 in the second half, 70%. So 50% and 70%. The average is 60%, right? No. Okay, you can't average 50% and the average of 50% and 70% is indeed 60%. But it does not apply if you're looking for an overall percentage. Why not? Okay, so well, let's think about this. Because in the first one, this is the goals made, and this is goals attempted. I don't have to really make this as formal as this. All right, first half and second half. Now, what am I doing? So in the first half, the player made 1 out of 2. Second half, he made 7 out of 10. So overall, this person made 8 out of 12, right? So it's 8 out of 12, and that turns out to be 66 or 0.66666, roughly 67%. Now, how in the world did we get 67% out of 50% and 70%? Well, you actually needed to know these numbers. Okay, so again, do not average percentages because the reference numbers can be different. And in that case, you have to add up these numbers. Right, you have to figure out, in this case, it's 8 out of 12, which is 67%. All right, so we covered a lot of things actually of this very common and practical topic of percentages. All right, I hope you've got enough information here. Again, you may have to review this and you may have to practice additional exercises. Definitely go ahead and do your exercises from 2.1 and 2.5, those 2 sections of the book, right, to keep up with and making sure that you understand these concepts. Okay, so this is lesson number 5. And until we see lesson number 6, I hope you have a great day and I'll talk to you later. I'll be back.